Hey everyone, welcome. So we are now officially in our pink packet, and we are going to look at graphing logs and their functions. So what we need to remember from our kind of like pre-6.1 chapter is that logs and exponential functions are opposites of each other. They're inverses. So everything is opposite of what we saw before, all right? And this is just a reminder that if this is the log version of an equation, then this is its exponential version. So this is written a little backwards than what I showed you with that E trick. So let me just show you here how I did this one more time. And I can write a log as an exponent by making this curly E. B to the y power equals x. Again, you always start with the base, jump across the equal sign, and then jump back. So b to the y power equals x. B to the y power equals x. So let's take what we know so far, and this is from our previous chapter if we were graphing y equals 2 to the x. So just a reminder, we would make our table, and these were our x values that we used for our table, and this is in the format of y equals b times g to the x power. So what we're right now seeing is g, the growth factor, what we should multiply it by over and over again. So if we want to see the y-intercept, we'll have to write in that number, and since b, our y-intercept, multiplies to g to the x, the number you can multiply that doesn't change its value is 1. So what we learned in our last chapter and in Algebra 1 is that we have a y-intercept of 1, and that we should start multiplying by 2 over and over again. So multiply this by 2, multiply this by 2, and if we're multiplying by 2 this way, then we're dividing by 2 this way, which gives me 1/2 and 1/4. So that is all of these points that you're seeing, 0, 1, 1, 2, 2, 4, 3, 8, and even -1 with 1/2 and -2 with 1/4. And then these are other points that aren't here. And the same thing would happen with 3 to the x. So just to show you another way we could have done this, you could just put these x values in directly. So 3, anything to a 0 power is 1. 3 to the first power is 3. 3 to the second power is 9. And then if you realize that you're multiplying by 3 this way, then you're dividing by 3 this way. And here are those points. So this was from before spring break. And what we do remember from all of these is that with this arrow, it's going right and it's going up. And this arrow is going right and going up, and nothing's stopping it. But as this one starts to move left, and nothing's going to stop it from moving left in either graph, so we put -infinity, there is that wall, that invisible wall, which that's right across here. It's called the horizontal asymptote. And so this wall won't stop our shape from going left, but it will stop it from going down, and the wall stops it at 0. So what this box is just telling you is don't forget that there is a horizontal asymptote. It's of the equation y equals 0, that our domain in all exponential functions is -infinity to infinity, which we could also write as all real numbers. But our range is going to be stopped by the wall. So it goes from 0, smallest y, to infinity as our biggest y. So what's going to happen in a log function, again, we're not as familiar with logs as we are with exponents, is that since these are opposites of each other, what that means is everything is opposite of what it is. And so what we can do is we actually can graph these functions fairly simply. So there's a shortcut to this, and I'm going to share the shortcut with you. But what we can do is, okay, so let me back up a little bit. So when I say that everything is the opposite, that means what were the x's are now opposite, and they are the y's. We learned this about inverses sometime in first semester. And what were the y's are now the x's, because this is the exponential version and this is equivalent log version. All right, so I can actually just switch all these numbers out. Whoops, not looking at this very carefully. And then 1 and 2 and 4. So the easiest way to do this, and I'll show you here how we're going to do that, is you're still going to make your table, right? But this time, instead of putting the values in for x, they will just be going in for y instead. And then if you look here, you will actually see the exponential function that we'll be working with, 3 to the x power, and this one you can just view as 2 to the x power. So again, the only big difference is where we made x's have the set value, now it's going to be the y's. And I'll just do, 3 to the 0 power is 1, 3 to the first power is 3, 3 to the second power is 9, and then fill them in. So when we graph these, it is going to look a little different. So let's just finish this one up. So here I'm going to go 9, negative 2, and then I'm going to go, whoops, I just messed that up, didn't I? Sorry, it's not 9, negative 2. I messed that one up. It's 1/9. All right, so let's back that up. That one should not be here. So let's actually start with this point. 9, 2, and then 3, 1, 1, 0, and then a third, oh no, there's a third going down to negative 1, and then over 1/9, that's barely over 0 and going down to negative 2. And what you're going to see is your shape, oh, it's really hard to draw, looks like this. Well, better than that. So you're going to start to notice when I said things were opposite, lots of things were going to be the opposite. So first, our x's become our y's and our y's become our x's. That's a big opposite. Another big opposite is going to be our wall. Here we had a horizontal asymptote. Here what's going to happen is we are going to have a vertical asymptote. And vertical just means your line is going up and down. And so the way I remember that is L for log. L goes up or down. So I'm going to have my wall be right here. So my shape can't touch the wall and it can't cross the wall. So L's look like this. This is now your wall. And this has an equation instead of y equals 0, because here on this invisible wall, every y coordinate is 0. 4, 0, 2, 0, 1, 0, negative 1, 0. But in a vertical asymptote, this invisible wall, every x coordinate is 0. Here's 0, 4, 0, 3, 0, negative 2. So that's why we name it x equals 0. And now you're going to see your domain and range become the opposite. Here, where our domain was all real numbers, now our range is all real numbers. And where our range was limited, now our domain is limited. And you're going to see that in just a moment. So this arrow is going right, nothing stopping it, and it's going up, nothing stopping it. But this arrow, as I start to get towards it, it can't go left anymore. It gets stopped at 0, but it can keep going down, and nothing will stop it from going down, so I have negative infinity, and that's how you get those. So let's just take a look at this one. So again, I like to start with the easier ones. 4, 2, 2, 1, 1, 0, here's a half with negative 1, and then maybe a quarter with negative 2. So again, we've got this wall happening here, our vertical asymptote, and this stuff. And so just like before, nothing will stop it from going right, and nothing will stop it from going up. But this arrow is going to get stopped at 0 from going left, but it won't get stopped at going down. So again, new things. We have a vertical wall, and instead of our domain being all real numbers, it's our range that's all real numbers, and our domain will be stopped by the wall. All right? So just taking a look at a couple of things, we're just going to answer some of these. We're going to use this graph up here to answer some of these. So on what intervals is the function increasing? So remember, there's increasing and decreasing, and we look left, right, and this whole thing is increasing. There is no decreasing. So I put the smallest x to the biggest x with parentheses. Oops, sorry, that should have been here. Not paying attention. Let me get rid of that. That is not in the right spot. Let's take a look at this one. On what intervals is our function less than 0? So that's just saying one is its negative. So we have negative and positive. So in this stretch, it's negative, stops being negative or positive, and now it's positive. So it's negative from 0 until I get to this point, which is 1, 0. So it's negative from 0 to 1. Remember, we write these answers with our x values because the x's won't repeat while the y's could. All right? And then let's just take a look at one more. Let's take a look at this one. So for what values of x is our function equaling 0? So when is y 0? That's what they're saying. When this whole thing equals 0, so they're saying y is 0. And that's that point that I just wrote down. It's when x equals 1. All right, so a little bit there. So what's going to happen is we're going to take this parent function for logs, and we're going to start to add those familiar letters of a, h, and k. So let's go here, and we're going to have to make our little key because this didn't make it on there. So we're going to have our function. We could have a negative. We could have a. And then you're going to have the log, so log of whatever your base might be. We're going to have h. So h has always been contained in something. I called h the house. And in our last chapter, our house was in the exponent. Here our house is going to be in the parentheses, and then k is not in the parentheses. And they all still have their same jobs. So k, we'll start here, is going to be our up and down value. H is where we're going to take the opposite. And remember, that's your left and right direction once you do the opposite. And then your A is your stretch or your compress. And the negative is going to tell you to flip the shape. All right? So let's talk about what do you think the general shape is before we do anything. And again, I'm sorry about these notes. They're great notes, don't get me wrong, but there's not really a spot to talk about the shape. So I'm going to kind of come over here and make a little box. So here's your log with your base, and then, you know, whatever happens to be behind it. So I'm just going to put a regular x. So if your b is greater than 1, like that, right? Let's do it like this. And then the other option is if your b is in between 0 and 1. Same rules that I talked about on Monday. You know, it has to be bigger than 1, that's growth. It has to be in between 0 and 1, and that's decay. That was from our exponential chapter. And then what happens? So if it's bigger than 1, well, that's what happened here. These were bigger than 1, so it's still going to look like it's growing, right? And this is growing. But here we're going to think of our growth as the R in the word growth, a lowercase r, like that. All right? And then there is not one that is a fraction, so we might change that one. If it's between 0 and 1, then you know what? It's going to look like the exponential does. Decay looks like decay looks like decay. Now, if there is a flip, then realize this shape is just flipping over. Imagine even that line. So it's just going to look like, instead of going down, it's going to go up. It's going to go like this. And then this one is going to look like this. So this is if there is a flip. So I'm going to put an F for flip in there. I hope that makes sense. All right, so those are kind of our shapes. Growth still is growing, and decay still looks like decay. And when it flips, it just flips. Imagine what I drew was the x-axis. So let's really separate these out. So we're going to graph like we've been graphing. So let's just get started. So first thing I'm going to do is see what the exponential function would be if I were graphing this function. And that just is right here, 2 to the x power, right? That's what we're using. And since we're graphing the inverse, the opposite, we're going to make the y's be the set values, right? But we're going to still look at these as an exponential problem. So 2 to the 0 power, anything to a 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. And so if you're multiplying by 2 this way, then you're dividing by 2 this way. So another couple things is, let's get the others now. So this minus 3, that's in our house, so I'm going to take the opposite, and that's going to tell me to move my points right 3. So let's go ahead and start getting these points on there and moving them. So I'm going to start with, there's 0, 0, so 1, 2, 3, here's 4, 2, and I'm going to move it right 3. And then here's 2, 1, and it's going to go right 3. And there's 1, 0, and it's going to go right 3. And then that's it. I mean, I guess I could put -1 or a half a -1 and go right 3, but I really don't, I don't need to. I don't care to graph the fractions. So remember, this is growth because our base is bigger than 1. So this is the shape we're looking for here. Okay? Now we have to think about that we have a wall. And is the wall affected by the move? So if something moves up or down, it's pretty much going to look like it's in the same place as far as our graph paper goes. When things move left or right, that will affect our new wall, this vertical asymptote. So where the wall is here, it's now going to move right 3 and be right here. So we have a new wall of x equals 3, and then I can draw that shape. So it's still growing. It kind of looks like the lowercase r in the word growth. So let's do our arrows so we can fill this out. So it's going right and it's going up. Nothing's stopping it. It gets stopped going left. Whoops, not at 0 though. I'm not paying attention. At 3. But it can still keep going down. So now when I do my domain, it goes from 3 to infinity. All right. Let's try this one next, and then we're going to end with our toughest one. So again, our exponential function that we'll be working with is 2 to the x power. That's how we're going to fill out our table. Except we're going to be filling in the x's, or I'm sorry, the y's as our set value. And anything to a 0 power is 1, 2 to the first power is 2, 2 to the second power, and then multiply by 2, divide by 2. So let's talk about this, what's going to happen now. So now we have a 3, but it's not in parentheses. So this is actually our k, and this says we're going to go up 3. So this time my wall moving up 3 doesn't really change what it looks like. So it's just going to be here, and our wall is at x equals 0. So now I'm going to graph these points, but move them, these points and move them up 3. So here's 1, 2, 3. Here's 4, 2, and go 1, 2, 3. And then here's 2, 1, and go up 3. And then 1, 0, go up 3. And then that's good, because I know the shape growth, like a lowercase r in the word growth. So nothing stopping it from going right or up. It is getting stopped left at 0, but it can still keep going down. So now my domain is 0 to infinity. All right, let's take a look at this last one. So this time, our exponential function that we're going to be working with so your set y values. And what we're going to be using is 3 to the x. So anything to a 0 power is 1. 3 to the first power is 3. 3 to the second power is 9. So multiply by 3 this way, divide by 3 this way. Okay? All right, so again, it's the switching of the x and y's that's the only big difference here. So here, let's talk about what we have. So first we have a negative. So our shape is going to flip. Okay, and when it flips, where the y values would have been positive, they become negative, for instance. Okay, so that's a big difference. And then, that's an arrow, just got a little smudge. And then this 4 is in house, so that's my h, and so I'm going to be going left 4 because I should be seeing that as a negative 4. So based on other chapters, what we would do is if we had a negative, we would take our y values, and it's still going to be the y values, and whatever our a or our flip would change the y. So all of these y's are just going to become the opposite again of what they were. So that becomes 2, 1, 0, negative 1, negative 2, and maybe you remember we scribbled out the old y values. So what I'm going to do is go to 9, negative 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. A little off the graph, but I'm going to put it here. And it's not going to stay there. It's going to go left 4. So there's 1, 2, 3, 4. And then here is 3, negative 1. And now it's going to go left 4. 1, 2, 3, 4. 1, 0 is now going to go left 4. 2, 3, 4. And then I'm not going to worry about these because I do know the shape. If I know growth, because this is technically growth, 3 to the x looks like a lowercase r, then that shape is going to flip, which is the shape that we drew here. So before we connect our dots, remember this is our wall, and moving it left 4 does affect it. It's going to end up 1, 2, 3 right here. And so this is the shape that you're doing. So it's going to go right along that wall, not touch, not cross. So it looks like decay. So again, this arrow is going right, nothing stopping it, and now it's going down with nothing stopping it. This one's going to get stopped going left at, did it again, negative 4, but nothing will stop it from going up. So when I do my domain, my smallest x to my biggest x is negative 4 to infinity. Sorry, I gotta watch the time before my next class starts. Okay, we're good. And that is going to be our graphing for logs. We're definitely going to be doing some more, but I'm going to stop the video here because the second part of the video will just be graphing with our natural log.